Good day and welcome to the Alberti-Base. This arrived in the mail for me today, and I'll be explaining exactly what it is, how it works, how it's going to help me. But first, I'll be unboxing it because who doesn't like a good old unboxing? Let's get to that. So I'm actually super excited to be taking this apart, be opening the box. I've been waiting for quite a while for this. It's my new oscilloscope. And the reason I've been waiting quite a while is that it's actually imported from overseas, and with the COVID regulations and stuff, it took quite a while to get here, but I've been wanting one like this for my electronics lab for quite some time. I must say I appreciate the packaging, at least. Hey look, airbags. Another airbag, some more air. These people only ship me a bunch of air. I'm telling you, it's just air everywhere I look. Oh man, that's heavier than I expected. And there's some more air below it, but for now, let's get rid of the big box. We have a small box, and as you can see on the front, it says Keysight Technologies. And I'm really excited because you get a lot of brands of oscilloscopes, but it's universally known that Keysight's basically the best. You don't get much better than Keysight. Now this is a very entry-level Keysight scope, as you'll very soon see. But for the purpose of an entry-level electronics lab and my budget, well, this is about as good as it gets, and I'm very excited to start working with it. If I know it was more handy with a knife. There we go. First, you can see these people really value the instruction manual. Awesome. We'll open that later. Who needs the instruction manual anyways?
Why are we still here? Just to suffer?
In another package of pink bubbly wrap. Oh my life. Okay, here's a bunch of cables. Let's see what they sent me. I wonder if they included. Okay. The first little piggy is a power cable that won't work in South Africa. Second little piggy, if I can get this open again, is a power cable that also won't work in South Africa at all. What's in here? Calibration certificate. Oh, that's why it's yellow and stuff. I thought it was biohazard or something. It's actually calibrated this year. Okay, I trust them though because I've seen a lot of people use these scopes and, well, they're really good quality, which is why I'm really glad to have this. Another packaging. Oh my life, it is beautiful. Let the camera see that. I am so excited for this. In here, we have the Keysight EDU-X1052, a 50 MHz oscilloscope with 2 channels and 1 gigasample per second sampling rate. And I must say, it's beautiful. I love it. Let's show you how it works. Firstly, what exactly is the oscilloscope? In simple terms, it's a very advanced voltmeter. Yeah, nothing more. It's a voltmeter that can show you the changes in voltages that happen very fast, many times a second. If I use a multimeter, such as this one, well, what it basically does is it shows you the voltage, but it updates 2 times per second. In other words, 2 Hertz. Whereas this one updates 50 megahertz, or 50 million times per second. As you can see, here I have it powered up, and to the untrained eye it might look like there's just a yellow line there. And to the trained eye, it also looks like there's just a yellow line there because right now, as you can see, I have a probe hooked up here, but there's no actual voltage running across the probe. So nothing is shown here, that's just the line of 0 volts. But this can be used as a standard multimeter, and to show you that, I'm going to switch on my power supply right here. I'm going to dial it down to about, let's say, 5 volts. 5.3 volts is what it reads there. And then I'll take these 2 leads of the power supply and I'll hook them up. Okay, you can see the moment the scope touches the power supply, there's reaction on the screen over there. And so I'll take the power supply crocodile clips and I'll hook them up to the scope like this. When you look at the screen now, you can see the yellow line is still there, but it's a bit like set off from the base, and it's set off on the scale here exactly 5.3 volts. That's the scale. Okay, disconnect over there. You can see the offset right there. Now, being able to see the line on the screen doesn't really mean much. If all I wanted to see was that line, well, I could have just used my cheap multimeter instead of that expensive piece of equipment. But what it can show me is more than... Oh, hello. Cat's joined us. It can show me more than what just the line would be able to show. And to show you that, I have a simple DC motor over here, and I'll be hooking this up to the oscilloscope and my power supply, so you can see what exactly the voltage across the DC motor does when connected to the power supply. And I'll show you that right here. You can see the voltage is like filled with a bunch of random spikes and noise due to the rotation of the motor. When I touch the motor, the line moves down a bit and up and down and up and down and up and down. That's what the voltage across the motor does. And so we can zoom this in and out, and what we can also do is freeze the frame. And there you can see, even if I disconnect it now, we can examine the freeze frame in all its glory, and that's the type of signal the motor is sending out or using. And we can move that around. So that is what happens across the motor. And in a future video, I might explain why a DC motor does this. But the fact that the voltage does this with these random spikes is something that no one with a normal multimeter would ever even be aware of. I feel like a doctor or something using a stethoscope to peek into the circuit and see what exactly is going on here. It's actually quite cool if you ask me. Now, as you can see here, I've also hooked up one of my ginormous capacitors that I use for Tesla coils in parallel with the motor, because I've heard somewhere that a capacitor can be used as a smoother for voltage. And while that is correct, let's see the effect that a smoothing capacitor has on the voltage across the motor once I switch on the circuit. Watch this. There you go. As you can see, with the capacitor in parallel to the motor circuit, there is still the occasional spike, but much of that whoosh noisiness is just completely eliminated from the equation. So the capacitor definitely works as a voltage smoother, and while we know that in theory, I think it's so much gooder to actually be able to see it in practice. Now, as a very special treat, this one hasn't actually been shown operational in a video yet, but I'm doing it today because in my first Tesla coil video, I briefly mentioned that we need a heat sink on our transistor because the circuit is constantly wasting power. But without the oscilloscope, I wasn't really able to show you guys how the waste of power looks like. And so we're back to magnetic fields and forces. Go watch the Shocking Yourself with an Arduino video because that's where I explain it. And then you can remember that what I said is you need a changing magnetic field or a changing voltage across an inductor like this one. You need the magnetic field to be changing for it to actually induce a voltage in the secondary coil across the magnetic field. Because a constant magnetic field isn't going to do anything. So we need a changing magnetic field. So the problem here is all the parts where there's a constant magnetic field, power is being wasted because it's not being transferred to the secondary part of the Tesla coil. So I'm going to set it at a low voltage, and then I'm going to show you what this oscillation looks like on the oscilloscope. Check this out. You see there, that is the waveform even by the voltage. It makes a dip over here and then up, and then it's basically like flat there on the top. So for this entire part, where there's no changing magnetic field, power is constantly being wasted by the Tesla coil. But you want to see what's cool? Like, I feel like Luke Skywalker doing this. Watch when I move my hand closer to the top right of the Tesla coil. Watch how the waveform actually reacts. Now if you check the power supply here, this is running at 7.6 volts. But for fun, I'll take this, which is something to make some sparks with. Just check this out, by the way. Also reacts to the steel. And then I'll bump the voltage up like very high, and we can see some sparks, and we can also see what the sparks does with the Tesla coil, just for like interest's sake, just for doing it. Watch this. Dialing up the voltage, you can see the shape and size here increasing. Let's just focus. And you can see the gradient here has decreased a lot. So with higher voltage, like even more power is being wasted between these, if you see this. Now, let's make some sparks. There's a spark. You can see the spark generates a lot of noise coming off from the top of the Tesla coil over here. This circuit hasn't exactly been tuned for optimal resonance, but it works and it makes some sparks up here. They're not very big because I've not done much tuning. Let's just max out the voltage. We'll show you what it looks like. As you can see, it makes its own spark there, and it's quite willing to make a spark coming off my scraper thingy over here. Well, there you go, ladies and gents. This was a bit of more basic unboxing style video, but it's sort of like totally my favorite piece of equipment I have in the lab here with me. It's awesome. I don't know what I would do without it. And using this, I'm going to be able to show you so much more of what's going on inside electronics in the future. And so for most of my videos, this will actually play a role, and I'll show you just what exactly the oscillations are doing inside the circuit. So stay tuned for that. If you like this video, please leave a like. If you have some questions or some stuff you want me to peer into, see the secrets of, reveal the internals using my fancy new oscilloscope. If you have some stuff I can look at, please drop them in the comments. I'll be eager to take a look and show it in the next video. Also, please subscribe, hit the bell button, and also share this video with your friends, because, as I promised, this coil is becoming musical the moment I hit 100 subscribers. So, let's do that. Anyways, thank you for watching, have a nice day, Alberti-Base, out.